All right, hello everybody. This is a summary presentation of my Noodle Lab or Noodle project that we do with my students. This is a really fun lab. I think it gets maximum engagement and maximum learning for the unit that we're currently in, which is design process, right? How do students learn how to design a product, to use the design process and key terms that we're understanding in class to maximize their abilities and to maximize the output of what they're designing, right? It's very important that students understand why the design process is important and why it's valuable to getting a good outcome in the end. So as you can see, a few pictures here to start us off. Just a few pictures of the towers that we've done, and I'm going to go over the different rules and processes for the 2-day lab. It's a 2-day lab, so it's very, very important that it's a 2-day lab, and I'll explain why we do it as a 2-day lab or project, as we like to call it. So 2-day group lab / project with data, an information sheet to fill out, right? Students are assigned group leadership roles. I love giving students leadership roles and seeing how they operate within them. This lab's even better because on the second day, they get to kind of assess what they did right, wrong, or assess whether or not it's something that they want to do or do they want to switch or change, and see how they can modify their process to make their process work best for what's in this group assignment, right? We need to make sure that they can put the best pieces in place for this group assignment. And they also have to utilize a limited source of materials to be able to do that. So in this lab, they have 26 noodles, 1 yard of tape, 1 yard of string, and 4 marshmallows. And they can modify these things. We'll talk about this in a couple slides, but they can modify these things any way they want outside the fact that they cannot modify the marshmallows in any way. They have to be the way they came, right? And we'll talk about what the rules are for that lab here in a second. The actual beginning of the lab. So students walk into the room and they pull out of a hat one of 4 numbers, or 5. It could be 3, depending on the size of my group, but usually groups of 4. Right, so they'll pull out group 1, and it could be in a job assignment, right? So that's what they are for the group. Group 1 recorder writes everything down and makes sure they have the sheet filled out with the help of everybody in the group. Group 1 builders, they're the people that actually do the construction. Does that mean other people can't help? No, in their group, they all can help with different assignments, but each person's responsible for that. So whenever I walk around to the tables and they're having an issue, we defer to the group leader, right? The group recorder is going to show me where they have followed the steps of the design process, right? And show me how they've recorded what they've actually done and show me their acknowledgement of certain terms. And the builders are going to be responsible for following directions from other people. So it's very important that everybody fills their role for this assignment. The rules. So simple rules, very easy to understand. It's a competition, right? Each group is able to compete with the other groups. The tallest tower wins. Students must build the tallest possible tower while filling out a worksheet detailing the design process and finding key terms, right? Tallest possible tower wins in this scenario. The students put all of the noodles together. They can use tape to bind them. They can use a string to bind them if they want to. I wouldn't recommend it, but they can use tape. They can split the tape, cut the string. They can use the string as a guy wire. They can do anything they want. As long as they don't mess with the marshmallows have to stay whole and intact. The students must put a marshmallow on top of the tower to cap it off, to add weight, which would cause the tower to possibly lean, tilt, fall. So the tower has to be relatively structurally sound. The students have a second attempt. We're going to talk about this in a couple slides. We'll have a second attempt to improve their teamwork and modify their design and the process from the previous day. So we'll talk about that in a second. Students may have no more materials than the ones given. You break your noodles, that's your own deal, right? If I give you 25 instead of 26 and you didn't count your noodles, that's your own deal. You messed up your own process. It's up to students to be responsible for what is given them and responsible for handling the tasks. It's very funny. This picture that's on the screen, this group actually failed horribly the first day, and this is them on the second day actually all participating in the group assignment. So this group failed really bad in the first day, and only 2 of them participated, and they participated whole, and then the rest of them kind of didn't do anything. And on the second day, they actually achieved a pretty decent tower. They didn't win, but they achieved pretty decent tower. And then the last rule is the 4th marshmallow must be placed on top of the tower and must freestand with a given materials for 15 seconds, right? So it has to stand up. It has to be stable. It can't be something that stood up for a second and then fell over. It's got to be a structurally sound design. Here's the sheets that we record, the data sheets that we record with. We've got the group leader, group builder. They have to put there on their names what they did. It's got rules, simple rules. Here's what you need to do. Do not tear the marshmallows. It's got material list, right? So they should count up. It says 25 on here. It's really 26. They should count their list of materials. It's got vocabulary, right? So how can we inject the vocabulary that we've already learned and translate it into learning about building, right? It's obvious that we have to optimize our output and optimize our participation to achieve a goal, right? We have to continually try to make this better, and having a 2-day process is making this better on the next day. How can we achieve getting as close to 100% as we can, right? We modify. Well, how do we get to optimization? We have to modify our design to make it better, right? Refine. We have to refine. Even if we achieve a maximum height on day 1, how can we refine it to make it a little bit better? Is there a little bit of refinement that we can change? Criteria and constraints. In my field, and pretty much in every field that's ever existed, criteria and constraints are the 2 most important words that exist in this chapter / unit / class, right? You have to understand what you need to do and what you want to do, and what are the things that are limiting you, like the noodles and their frailty, and the weight of the marshmallows, and your limits on materials and things like that. And then making a model, right? Something to look at in a prototype, right? Maybe a sketch to look at it for concept, and then a prototype is the testing on day 1 and the actual product on day 2, however you want to do it. They then go through all the steps of the design process. It's important for them to record how they achieved each step of the design process. Now, there's some steps in the design process they'll never use. They're not going to write a design proposal. It's not going to happen. That could be an NA on their sheet. That's fine. But how did they achieve getting an answer to what they want to build? They brainstormed. They thought of ideas. A lot of times they have the ability to go on the computer and look and research things up, and students don't even think about doing a little bit of research of what a tower should look like, right? What is the most stable structure in tower building, right? It's a triangle. Students don't even go to look at those things. You have students that are building square towers. So they end up getting to do more research on day 2 than day 1 because they didn't think about doing research at the first part. It's about learning why these steps are important, right? Understanding our limitations. Entropy is disorder in a system. Every system has disorder. Understanding where the entropy is, where the limitations are going to exist in this process. So they have to write stuff like that down. And then the other steps of the design process and filling in how they are important or integral to what they did. So they have to come through this process understanding that feedback drives this whole process. Feedback is the thing that tells us whether we can proceed, or how we need to proceed, or should we proceed, or do we need to go back steps? And we can move forward and backwards on the design process based on feedback after each step, and the grand feedback at the end that tells us how well we achieved our goal. So day 1, students are given the overview of the 12 steps of the design process. We talk about the design process. We've already been introduced to the design process on day 1 of the unit. Day 1 of the lab, we go back over it, why they're important, and students are left to their own devices to try to build this thing. And then they have 50 minutes in the first day to put this together. It's a group work achievement that they do together to see if they can reach their goal on day 1. There's a winner on day 1, but really the winners are on day 2 after everybody has had exposure to this lab. This is day 2. If you look at the picture, these are the actual top 2 groups in the class that day. The one in the back was the loser. The one in the front was the winner. They were within an inch of each other. I think they got to 38 or 39 or 40 inches. I can't remember exactly. One of them was 38, and I think one of them was 40. And they're very two different ideas, and even really two different ideas from day one, right? So on day one, both built a tower that freestood, and on day two, they changed their approach. The one in the back is more of a traditional tower design, and the one in the front is all gravity-based. The marshmallow weighs down the sides, and the sides push out against the marshmallows on the bottom, and it makes it freestand, and it's a freestanding tower, which was kind of cool seeing the students do something of that nature and be that creative for a Noodle Lab without having to be rigid with all the little things that you would normally think you had to do. It allowed them to go taller. This is probably I think this is the tallest tower we've ever done. It's pretty good. So students are given a review on day two of what we did on day one. And we talk about successes and failures and what they thought and what they used in the design process and what they didn't use and how did the group work and things like that. And then when we get to the point in time in class where they get to break off to do their lab, they go and try to use previous knowledge from the previous day and do the lab over again using previous information, feedback from the day before to guide the design process all over again. And if you had success on day one, you probably don't need to start on the step one of the design process. You might be able to start on step 4 and just modify from there. If you had horrible success on day one, you're going to start the design process over and utilize anything that you thought was good and then modify it to make the next day better. So they're really getting a great understanding and grasp of why the design process is important and how they can use previous failures, because failure is important. It's the most important thing you're ever going to have in life, is understanding what not to do, right? I tell my students all the time that entropy is going to exist in everything you do in life. It's disorder. It's disorder in a system. It's not just disorder in an energy system. It's disorder in every system. And how we can navigate and manage the disorder in all of our systems allows us to succeed in the future. So managing what we know isn't going to work, or what we know isn't right, or what we know isn't going to work with other students allows us to make better processes for the future and for the next day, especially in this lab. And then conclusion. So this lab, when done right, sees students understand the importance of leadership in individual roles. The goal of CTE is for students to understand how process and role makes them a better worker. Technology class, as long as I'll ever teach, is not about robots and flying ships in the air. That's part of it. But if you're not good at processes and managing processes, you're never going to be good at the technology part of it. The actual lab and robotic stuff and the cool technology stuff that these students get to use is not important if they can't understand how to manage and modify and optimize what they're doing and get an appropriate output, which is why we do labs like this that kind of pull as much possible out of the marrow of the idea to allow them to connect these things together. And then the labs progress throughout the year. So students are able to make changes in the previous day's design. They can make changes in their roles, right? Sometimes managing a process is managing a group of people. A system could be a group of people, and you have to sometimes pull somebody out of a role and put them in a different role because they'll succeed there. So they can manage their roles and understand how they interact with each other through teamwork to make the best possible output. And then students often vote to change roles. They'll ask, can we change roles? They can't change groups, but they can change roles. Students get to see the value of each step in the design process and how each step is used to create an optimal design. That's really what I want them to get out of it. Why is the design process important, right? It's not just some dumb set of steps. It's a set of steps that leads you to conclusions and leads you to answers. And then if you can't get to the next step or the next answer successfully, it allows us to back up using feedback to better understand how to move forward by going backwards, up, left, down, upright, whatever you want to call it. So the design process is important. It's one of the most important things. And this lab/project really shows students, and it's fun. They get to get candy at the end, and they get to win candy prize, whatever. But they really get to have some pride in building something and they get to have some pride in seeing their actual steps and their actual ability work. So that's my design lab / design process lab / project. So thank you. I appreciate it. And that is all.